Hi guys, this week we're going to keep talking about chemistry. We're going to talk about chemical and physical properties and chemical and physical changes. Also this week I have highlighted the key vocab words in yellow, and so if you're someone who likes to make a vocab list, that is a great place to look for the keywords. First up, we're going to talk about properties. Properties are any characteristics that can be observed, and there are chemical and physical properties. In the picture, the turtle's properties could be green, slow, large. Any word that describes it would be a property. Physical properties are properties that can be observed without changing the identity of the substance. So that means that you can notice these things without changing them into something else. So examples of this are luster, which is another word for shininess. Metals have luster. Malleability and ductility, which we talked about before. Malleability is being hammered into a sheet like aluminum foil, and ductility is stretched into a wire like a copper wire. Melting point and boiling point, which I'm going to talk about in just a minute. Density, which means how many molecules are packed into a certain volume. Solubility, which means how well the thing dissolves in another thing. So remember that if you're testing solubility, you would be making a mixture, a solution, and mixtures are not chemical, they're physical. So that is why solubility would be a physical property. And then specific heat, which we talked about at the very beginning of the year when we did burning money, which means how much heat can the liquid or the thing absorb before the temperature rises by 1 degree. So water, we talked about, has a very high specific heat because it takes a lot to boil the water. And something like alcohol, which we use to burn the money, has a very low specific heat, and so it burns at a much lower temperature. Two important physical properties are melting point and boiling point. These are the temperatures where the thing will either melt or boil, so change from a solid to liquid, or boiling point would be changing from a liquid to gas. These are both phase changes, and so they are physical. They are just the same thing as changing into another form. So water is still water if it's a liquid or if it's a gas or if it's a solid. So it's considered to be physical. The other type of property is a chemical property. And this is something you can only observe by reacting the substance with another substance or by altering what it is. So examples of that would be flammability. To measure whether something's flammable or not, you would have to catch it on fire, and that is actually a chemical reaction. The ability to rust. Once something rusts, it cannot be returned to its unrusted form. And reactivity. Reactivity we talked about a little bit when we did periodic table, and we talked about how some elements have more reactivity than others. Very reactive elements are the alkali metals and the halogens, whereas something like a noble gas like neon or krypton wouldn't react at all. Next, we're going to talk about chemical and physical changes. So how these substances turn into other things can either be physical or chemical. If it's physical, the identity of the subject hasn't changed. And if it's chemical, it has changed into something new. So change just means altering the substance. If the identity changes, if the answer is yes, that's going to be a chemical change, C for chemical. If the answer is no, that's going to be a physical change, P for physical. So physical changes, like we just said, do not change the identity of the substance. If it was water before, it's still water now. The example of that would be ice. Keep in mind that just because it looks different, so just because the ice cube looks different than the liquid water, doesn't mean that it's changed into something else. Same thing with freezing Kool-Aid, tearing paper, or boiling water. Those things are still what they were when they started out. So they would be physical. Creating a mixture would also be a physical change. So if I mixed the Kool-Aid and the water, that's physical, that's not a chemical reaction. And I could get the Kool-Aid and the water back through filtration. I wouldn't have to do a reaction. The second type of changes are chemical changes or chemical reactions. They're interchangeable words. In a chemical reaction, something new is created or something is broken down. And those are things like burning paper, digesting food, and the electrolysis of water. Anytime you burn something, that's a chemical change. Something new is created. So some ways that you know a chemical change has happened could be that light is created, heat is created, new gas is created. So be careful with this, because this does not mean water boiled and it turned into water as a gas. It means that there was a reaction and a gas that wasn't there before is now being created and escaping into the atmosphere. A color change. So also be careful with this, because if I just add food coloring to water, that's not a chemical change, that would be physical. But if a reaction is causing the color to change, that's chemical. And finally, a formation of a precipitate. This is a solid that falls out of a solution. So an example of that would be like our rock candy, where the sugar crystals are supposed to fall out of the sugar water. That's a precipitate. All right, take a second to quiz yourself, pause the video, see if you can get these answers right, and then press play and see if you got them. All right, see if you got the right answers. Melting cheese would be physical, because the cheese is still cheese, even if it's in a liquid form. Burning wood is chemical, that's combustion, it's a type of chemical reaction. Milk souring is chemical. Wadding up paper is physical, it's still paper, just in a different shape. And a bicycle rusting is chemical, that is an oxidation reaction. All right, that's it for this time. Make sure to do your discussion post, and I'll see you again next week. Bye.